Hello and welcome to the walkthrough for the Key Assessment 2, and this is for the vocational courses, but also part 1 for the adult courses as well, and full-timers. Okay, so as usual, make sure you put your name on the front and you've filled in any of the access arrangements that you've used. Okay, and if you haven't made any use, we can tick that box there. Okay, and don't forget to sign as well. Okay, so straight over, question 1A, and we've got a sequence. We've got a sequence of numbers, and as we can see here, if we follow this sequence, as we go along, each time we've added 3, so that means we just carry on 1 and we add 3 again to give us 13. Okay. The next sequence, a bit different, because this time, as we've gone up, first off we've added 2, then we've added 4, then we've added 8. So what's actually happening here is what we're adding up is going up by 2. Okay, so we've times that by 2, times that by 2. So we would do the same again. We would times that by 2. So then we would add 16, and 16 add 16 gives us 32. Okay, and the difference between those two, this one because it's a straightforward adding sequence, it's an arithmetic sequence, and this one because we're multiplying is a geometric sequence. Okay. Still on question 1, part C. This time it's descending, so it's going down. So this time we've taken away 6 each time. So again, we carry on, we take away 6 again, and we end up with -4. And on part D, let's work out 3 times. Now the brackets have caused some confusion in the class. All it is the brackets are around that, so we know that that is a -6. So we can look at, we say, well, 3 times 6, and we know that gives me 18, and a positive times a negative makes a negative answer. Okay. Question 2, and again, another 4-parter, 1 mark a piece. And we've got a bunch of cards from a game, and we want to write down the appropriate number for each. Generally for these, you're looking at the card being used once. Okay, they haven't stated that, but it's a good idea to be looking at. So to write down the number from the card, that is a multiple of 5. There we go. So if multiple of 5, we've got 15. So 3 times 5 gives us 15. Then we have a factor of 40. So something that goes into 40. And of course, well, staying with the 5s, we know 5 times 8 gives us 40. The next one, the number from the card, that is a prime number. And as we look through here, 13 is our prime number. Remember, a prime is something that only has 2 factors, 1 and itself. And this one, number from the card, that is a square number. And square number is what we get when we times a number by itself. Okay? And it's this one, 36. 6 times 6 gives us 36. So again, that goes in there. And that's our question 2 sorted. Question 3 is a pictogram, and it even tells us that the key is missing. Okay, so generally we don't have to put the key in, but if we were to, so we can say that we can tell them what 1 full circle equals. Okay, now the information we're given is that there are 48 street names ending in close. Okay, and if we look at close here, we've got 1, 2, 3, 4, 5, 6, 7, 8 parts of the circle, but more importantly here we've got just 2 circles. Okay, so that means 48 split between the 2, 1 full circle is 24. So when we want to work out how many street names end in avenue, this one, this circle is 24. But of course, we need to find one part of it. So 24 divided by 4, and that gives us the 6. So we've now got 24 plus 6. And that is going to give us 30. And that is our answer there, 30. Okay. Question 4, and we're on to some graphs. Okay. Now, with this one, the graph tells us that Ola and Pip make orange paint by mixing red paint and yellow paint, and this shows how much of each colour paint to use. So this is their mix line. So however much red paint and yellow paint they mix together, if they mix it in the right mix, they will get orange paint. Okay. Now, oddly, a little bit of a typo there, because it tells us that Ola uses 5 litres of yellow paint, and write down how much red paint Ola uses. So they've used the same name twice. They shouldn't. Okay. But what we're interested in here is 5 litres of yellow paint, which on our graph is here. So when we draw our line across, and this is what I always like to see, draw the line to our conversion line, and then we can draw the line straight down, and that line goes straight through the 4. So that tells me that she's used 4 litres. Okay. The next part of the question says that Pip uses 10 litres of yellow paint, and how much orange paint do they make? Okay. So here again, it was 10 litres of yellow paint. So on the yellow paint side, we're now dealing with their 10. I'm going to use different colours so we can see that this is part B to the question. So 10, again, we draw the line across to where it meets, and it only just meets, but it's good enough for us. And then we drop down to there, okay? So what that means is, for 10 litres of yellow paint, they're going to need 8 litres of red paint, which gives us a total. So we've got the 10 plus the 8, that gives us 18 litres, okay? Because it's wanting to know how much of the orange paint, how much is mixed, okay? So, question 5, a number is divided by 8, and the answer is 43 remainder 5, and work out the number. Now, what people have done and made the mistake, they've added the 5 to the 43 and then times it by 8. But the 5 was a remainder, and it is a remainder of 5 whole numbers, not 0.5. So what we're immediately interested in is, well, if I do the 43 times by 8, so let's do that. 43 times by 8, okay. So 8 times 3 gives me 24. So I carry the 2. 8 times 4. And we know that 8 times 4 gives us 32. Plus the 2, so it gives us 34. So we carry that. So we've now got 344. And we are close to it. Now we deal with the remainder 5. So now what we do is we take our 344 and we add our 5 to give us 349. And that is our answer. Okay, 349. Okay. So now, question 6. We've got a question about profit. And with this, we know that Quinn buys 200 toys for £4 each, and he sells the toys for £5. We want to know the least number of toys he must sell to make a profit. Okay. So when we look at this, if we've got 200 times 4, and well, obviously we've got 0, and we've got 8. So that means he paid £800. And now, you can do 200 times 5, which is going to give us 1,000, and that tells us how much money he's going to make. But we want to know how many toys he must be able to sell. He needs to make that much money. Okay. So what we need to do is we can now do our 800 and we can divide it by 5. Okay, so 5 goes in once, and we've got 3 remainder, and then it goes into 36 times. So we now know we need, if he sells 160 toys, he'll make £800. But we want to know the least number of toys he must sell to make a profit. To make a profit, he must make more money than the 800, which means instead of just the 160, he must sell 161. That will give him his profit then. Okay, the 160 only evens out. The 161 means the profit. Okay. So then we've got final records costing £25 each, and he wants to buy 2 vinyl records, and he's going to save £8 every Saturday. Now the offer is buy one and get another one for half price. Okay, so we've got 25 divided by 2, and let me put that where I can work it. I'm going to actually use the space below here. So we've got £25 divided by 2. So 2 goes into there once, goes into there twice, and we've got 1 remainder, and that's, so it gives us 12.5, but being money, it's £12.50. So we've got our 25 plus our £12.50, and that's going to give us £37.50. So that's how much money he needs to save. Okay. Now he's saving £8 every Saturday. So we can just work out, we can divide, see how many 8s go into that, and so on. Or we can just do a quick build-up method. Quick 8 times table. So we start off, we've got 8, 16, 24, 32, and we've got 40. Okay, now £37.50 is less than that, but more than that. So we're somewhere in the middle, but that means we need to save that much. Okay, so we've got 1, 2, 3, 4, 5 weeks, and that is our answer for that one. Okay, now sometimes it's worth knowing what the mark scheme wants from our questions. Okay, and in this case we're on question 7. What we can look at, if I look at the actual mark scheme, we've got the 25 divided by 2, or 12.5, to work out the half price. Then we can work out how many weeks, and it doesn't matter which way we do it, okay, because they have done the divided by 8 on the mark scheme, but it also says multiple may be seen in a list, which is what we did. Okay, and then it's obviously 5 with M2 awarded and no errors, and that's what we're after there. Okay, so then if we flick on to part B of the question, and it says, in fact, the offer is only for 1 week and there are no new offers. And what does this mean about the number of Saturdays he needs to save for? And that means he's only getting the half price, buying the second one half price for 1 week. And that means the remaining weeks, they are all going to be full price. So that means the answer, it will be greater than the answer to part B. Okay, it's only 1 mark. We don't need to show anything. That's how it is. Okay. And then on to question 8. We have a list of ingredients for lentil soup. Okay, so what we can do here, we need to find out how many grams of lentils are needed to make the soup for 10 people. Okay, at the moment we've got a list for 4 people. So if we look at our list, I'm going to lay it out slightly differently. Okay, so at the moment for 4 people we need 170. Okay, and we need to get to 10 people. Now, we know 4 doesn't get straight to 10. Okay, what we can do, if we halve it to get the answer for 2 people, we can then times that by 5, can't we? Or we could halve that again to get the answer for 1 person and then times it by 10. It doesn't matter which way we do it, as long as we get to that point. The idea is we still, because 4 doesn't go, we can't multiply 4 up to 10 cleanly, we have to reduce it and then multiply it up. So if we're going to go from 4 to 2 people, we're just going to halve it. Okay, so we halve that, and what we're going to get is, well, that's half of 170. And we have got 85 for that one. Okay, now to bring that up, I'll go with the easy way. We can times that by 5 now, but what I want to do, I want to know the answer for 1. And again, we have to halve that. And half of 85 is 42.5. Okay, so it's 42.5 grams of lentil per one person. And we can now times that by 10 to get to our 10. And with times it by 10, we're just moving at decimal point ones. So we've ended up with 425 grams. And that is our answer. Okay. Now, I haven't actually shown the working out for each part of that, the divided by 2, the divided by 2, and then the times by 10 for each part, okay? Our evidence is there in the table, okay? If you've done the actual calculations on the paper, great. Keep going with it, all right? So, question 9. We have got numbered discs in 2 boxes, box A and box B. And we want the ratio for the total value of the numbers in box A to the total value of the numbers in box B. So we've got A and we've got B. Okay. So if we look at it, for A, we've got 2 plus 3 plus 2 plus 4 plus 9. So when we add all of those up, we get 20. And in box B, we got 1 plus 1 plus 1 plus 3 plus 2 plus 9 plus 4 plus 4. Do it nice and quick, and that gives us 25. And so far, we're doing all right. We've got a couple of marks, but it wants the answer in its simplest form. Be careful of that because it caught out a lot of people. And we can see from here, we've got 20 and we've got 25, so we know 5 goes into each. 5 goes into 20 4 times, and it goes into 25 5 times, and that is our answer in its simplest form. There's all 3 marks. Okay, be careful, because what happens is people do that first bit and think, great, I've got my answer, and miss a mark out. Very simple to do. So now for part B, we're going to pick out one disc at random from box A and write down the probability that the number on the disc is greater than 6. Okay, so it was box A. And when we look at this, if we look at these, we're looking for greater than 6. So that's not, that's not, that's not, that's not. So that means we only got 1, but it's 1 out of all of those. So it's 1 out of 5. Sorry, I haven't marked the page, but I'm writing that. 1 out of 5. Okay. Now, the mistake that people make is they write it, because it's a ratio question, they write it as 1 to 5. Now 1 to 5 means there's 6 discs, and there isn't. Okay, there's only 5. Do not write this in that form. It's probability. Probability does not go in that form. Okay, it's a 1 in 5 chance. Okay. So question 10, but into some algebra. It says work out the value of 2 times, and we've got then a squared plus 3a, okay? But they give us the value of a. So what we're actually working with now, if we deal with look at what's inside there, we've now got 4 squared plus 3 times 4 in the brackets, and then we're going to times it by 2. 4 squared, so 4 times 4 gives me 16. 3 times 4 gives me 12. I'm going to add those two together. Leave them in the brackets for now, and then obviously we need to times it by 2. So 16 plus 12, and as we look at that, so we've got 28 there, and we're doing 2 times 28, which gives us 56. Okay, and again, it's one of those questions that when we look at it, if we look at the mark scheme, various things they want to see. So the 4 squared, or 16 or 32. So if we're working with those, okay. And then the multiplication, well, the actual solution itself, and then the answer, okay. So there's a bunch of different methods, okay, for these. But as long as we're hitting those signposts, it's all about showing them the work to gain the marks. 3 marks, we can see it's clear there, okay. And then we're on to a circle question. And it even tells us to use a pair of compasses. So I'm hoping that if you didn't have any compasses with you, that you asked for some. Because if you need equipment, be brave, ask for it. Because it might only be 1 mark, but could you imagine missing out by 1 mark, knowing that you didn't ask for a set of compasses? Okay. So the line shown is the diameter of a circle, center X. So this is the diameter, this is how wide the circle is, and the center is X. So that means that is the center for our circle. So we can put the point of the compass on there, and we can open it out to the end of the line. Now, a couple of different ways to do these. We can turn the paper around, we can fight with it. Don't try and keep it vertical, okay? Allow the compass to draw the circle for us, okay? So pull it across, drag it around, okay? I know it gets a bit awkward, especially with my hand in the way, but you can see that now, okay? We can, as I say, we can just lean it over and we can turn the page around, okay? That will do us. And that's our circle. Now, I have to show this because it made me chuckle at the time, this is the mark scheme for that. So 1 mark, correct circle drawn. Mark intention, but must have been an attempt with compasses, not freehand, okay? What that means is, if your compass were to slip as you were drawing it and it ends up a scruffy circle, you would still get the mark because you were doing the right thing, okay? But of course, freehand means no mark at all. So remember, if you haven't got the equipment, put your hand up, ask for it. So question 12. So company runs 240 trains and 1/8 of those trains are late. And the company is charged £350 for each late train. And they want to know how much they were charged. So first off, we need to find out how many were late. So we need to do 240 divided by 8 to find 1/8. 8 doesn't go into 2, so we carry it, and 8 goes into 24 3 times, and there's no remainder. So that means there are 30 late trains. I'm just going to put that there so I know exactly. 30 late trains. They're charged £350. Okay. Now, what we can do, a few different ways. I now need to do 350 times 30. Okay. And I'm going to use that method because, just as an idea, we've got the zeros there, cover up the zeros, because you're thinking, a lot of people were doing the same thing, 30 times 350, don't want to do it. But if I cover up the zeros, I've now got 3 times 35, which is a lot easier to do, isn't it? Okay. So if I do that, okay, so 3 times 5 gives me 15. And then 3 times 3 is 9, plus the 1 gives me 10. So I've now got 105 there, and this is the trick now. The 2 zeros that we hid, put them back on at the end. So that 105 that we worked out here, without the zeros, we now put those back in. And what we've got is 10,500. It's a very simplistic method, but it works for the likes of that. Do you have to do it that way? No. If you've got a method to show it and you're happy doing 350 times 30, do that one. Okay. This next one, we're into ratio. So we've got tea, coffee and hot chocolate. Now I'm going to rewrite that. Okay, so we've got tea, coffee and hot chocolate. in the ratio of 3 to 5 to 2. And I'm laying this out because I know I saw a few mistakes on this question and I know where it comes from. First thing we need to total them up. So 3 plus 5 plus 10, say plus 2, gives us a total of 10. So we need to share that 2,600 between the 10. And we know that if we do 2,600, we divide it by 10, basically we are left with 2,600. And that's 2,600 per each of those, okay? And this is the trick. Only 3 marks. It was how many coffees were sold. We're only interested in that. So we wanted to do the 260 times by 5 because there's 5 parts, okay? So we've got that there. And we end up with 1,300, and that is it, because they only wanted to know how many coffees were sold. I did see you didn't need to work out the other 2. You can do, and you can add them up to make sure your numbers match, that's fine, but that is the only one they're interested in, okay? What I saw people doing, making the mistake, they were putting how many teas or how many hot chocolates, or putting all of them. They only want to see that one. Okay, so again, be careful with that. Just to prove our mark scheme again. So we've got our 2,000 basically divided by the 10 to give us the 260. Then we're timesing it by 5 to get our answer. Okay. If you put the others in instead of that, you only score 2. You miss out on the final mark, okay? So again, a simple mistake to make and a simple mark to lose, okay? And that brings us on to question 13. So, question 13, we're told that MN is a straight line, so we know that this is a straight line, and we need to work out the value of X, okay? Now, because we're given that, we don't need a protractor. It says not drawn accurately, don't measure it, okay? But we know a straight line adds up to 180, so we can do 180 degrees, and we can take away our 74, okay? Can't take 4 from there, so I have to borrow. That leaves me with 6, 7 from 7, 0. So we'll end up, that means that this is 106 degrees. And again, this was a simple mistake that quite a few people made. They went, great, I've got my answer, I know what that is. But they want the value of X, and that's 2 times X. So it's 2 lots of X is 106. So what we need to do is take our 106 and we need to halve it. Okay, so of course 2 doesn't go into 1, 2 goes into there 5 times, and it goes into there 3 times, and there's our answer, 53 degrees. So be careful with that, because it was 2x, 2 lots of X, and they wanted the value of X. We had to then halve that answer. Okay. (14) Rounding, and of course they've picked the worst, the most awkward type of rounding that we do, rounded to one significant figure. Remember, one significant figure means we're rounding to the first number with value, and it's 1.98. So we put a line after the first one, the 9 rounds up, so that becomes 2. So our first number is 2. The next one after the 3, so again that rounds up, so we've now got 4. And then for the next one we're going to add, and again the 7 rounds up, so that becomes 7, and it's 7 squared. Okay, so what we're going to be doing is 2 times 4 plus 7 squared. And of course we think in bid mass here, so we're going to do multiplication first. Well, actually we don't. Let's be strictly true here. Here we do the indices first. So 7 squared gives us 49, which we're going to then add to whatever the multiplication is. And 2 times 4, that gives us 8. and 8 plus 49, and that gives us 57. Okay, and again, it's always worth having a look for the mark scheme again, and it's the same idea. So we've got the correct rounding, 2, the 4, the 7, or the 49 gives us the first mark, all 3 gets us the second, and then the correct solution, the 57, with those numbers seen. And that is important because it says you must show your working. So if you got the right answer but you didn't show your working, you will not get any marks. Okay, it said when it says you must, make sure you do. Okay, you should be doing it anyway, but make sure. So part B, is your answer to part A an overestimate or an underestimate? And tick one box. Now, it's not enough just to tick a box. It wants a reason, it wants to know why. And if we look at each one of those, we rounded that up, we rounded that up, and we rounded that up. We rounded every number up. That means it has to be an overestimate. Okay? And the reason is because we rounded each number, or each value, I'll put, each number will do, up. Okay, that's all you need, because we rounded each of them up. It's going to be an overestimate because each value we've raised. And then on to these. Now this one was a lot simpler than it looked. A sphere has a diameter of 20 centimeters. Show that the radius of the sphere is 10 centimeters. Okay. Now, there's so many different ways of showing this. We could say that the radius is equal to the diameter divided by 2, halved. That's fine. We've done it. Okay. We could actually do it. We could say, well, we know it's half, so we could say that 20 divided by 2 gives us 10. Anything along those lines to get the mark. Okay, it's only one mark, so we don't need to go to town with that one. Okay, and again, mark scheme, it gives us, there you go, 20 divided by 2 gives us 10, or you halve it, radius is half diameter, diameter is double R. Okay, and these things get us the marks. Okay, the next one, I didn't see so many attempts, okay, and I can understand it, because you look and you think, I can't do that without a calculator. The thing is, they're only asking it in terms of pi, so we only do what we can do. Okay, so I'm going to use the space below, just because it gives me more room. So I'm going to do 4/3 times pi times our radius cubed. Okay, it's radius cubed, and the diameter is 20. Okay, so that means, and we've already worked it out on part A, the radius must be 10, mustn't it? Okay, so we're actually doing 10 cubed. Okay, so we're going to do 4/3 times pi times, and 10 cubed is 1,000. 10 times 10 times 10. Okay. Now, there's not a lot we can do with this at this point, okay? Because we need to basically, with that 1,000, we know the answer at the end of it. If we look at centimeters cubed, it's going to be something pi centimeters cubed, okay? So we take that pi out of it there because we've put it straight up there. So we need 4/3 of 1,000. Now, we can do, there's a bunch of different steps we can do. Simplest thing, because we know we can divide by the bottom, multiply by the top. Now, if we do 1,000 divided by 3, we're going to end up with a recurring decimal. We don't want to mess around with that without a calculator. So the simplest thing to do is we can just times the 4 times 1,000. So that's going to give us 4,000. But we still need to divide it by 3. And we just said we don't want to divide it by 3 because we're going to end up with recurring decimals. So again, being in terms of pi, we can leave it in the shorthand version, and we can just say then that it's still divided by 3, and that's what we can use for our answer. 4,000 divided by 3 pi centimeters cubed. Okay, and that is our answer in terms of pi. And again, back to the mark scheme, things that we want to see. So they want to see the 10 cubed or the 1,000, that's your first mark. And then for our answer, we're looking, that is our answer, 4,000 over 3 pi, and then obviously centimeters cubed. So it gives us then a variation on that, okay? But also, it says that if we've used the diameter instead of radius, we get 1 mark because at least we tried, and we've done some working on the right idea, we just used the wrong number. We can accept 133333 for the 4,000 over 3 because of course it said it would give us a recurring, okay? And then we can work with that. Question 16. Here we've got given information, we've got D equals 800 divided by W. Now the D represents the number of days to complete a job and W represents the number of workers needed. And they're telling us to assume that the job needs completing in 20 days. So that means that the D is now 20. So 20 is equal to 800 divided by W, and we need to find out W. Okay. So all we need to do is we just need to do 800 divided by 20. If I show it this way, 800 over 20, we've got a 0 at the end of both, so we can divide them both by 10, bring it down, and I've just got 80 divided by 2, which gives us 40 workers. In part B, it tells us that the job needs completing in fewer than 20 days, so that's less than. And what does this mean about the number of workers that are needed? Well, if we need to do the job in less days, we are going to need more workers, more than 40, okay? Because if that number reduces, it's going to go into 800 more. So it is greater than the answer to part A. That's all we need on that one. Question 17, and it's to do with the circles. A chord is drawn on a circle. Which statement is correct? It tells us that it must be longer than the radius, equal in length to the radius, shorter than the radius, or it could be longer, equal, or shorter. Now, quick circle, badly drawn as ever, but a chord is the line that goes from one side of the circle to the other, but it doesn't pass through the center, because if it passed through the center, that would make it the diameter. And they're talking about being longer, shorter, or equal than the radius, and our radius goes from the middle to one side. Now, depending on the placement for that line, it could be shorter, equal, or longer than the radius. So it's the last one that we want. Now, question 18 deals with volume of 11 cubic centimeters and a density of 8.5 grams per cubic centimeter. So what we're looking at is we've got density, mass, volume in that triangle. Okay. Now what we're after, we need to work out the mass. So we need M. M, we cover up, M is equal to D times V. So we can now substitute in what we know. The density is 8.5 and the volume is 11. I'm going to do 8.5 times 11. Well, we can break it down. 8.5, 10 and 1. So we know 10 times 8.5 is going to give me 85, no decimal point there. And 1 times 8.5 gives me 8.5. And of course I've messed up my place value, but you get the idea. So I've got 85 plus 8.5. So that's going to give me 93.5. And there's our answer. Question 19. The table shows information about the marks of students in a test. We've got school A, school B, and this is the mean mark, so it's the mean average, and then the range of marks, so that's the difference between the highest and the lowest. It says tick one box for each statement. So on average, school A had higher marks. So we're looking for the mean average, and we can see there that yes, school A's average mark is higher, so that is true. Next statement says there are more students in school B. Now with this, we know the average mark and we know the range of marks. We have no information about the amount of students in either. So that means we cannot say for definite, so it may be true. It could be, it might not be. And school B had the greater spread of marks. And the greater spread of marks means a higher range, the difference between the highest and the lowest. And of course, when we look at there, we can see school B has got the higher range. So that is true as well. Question 20. We've got A and B, and it's to do with standard form. Now the mistake people make is they see this and they do it in standard form without working it out first. We've got 0.6 divided by 100. So when we do 0.6 and we divide by 100, we just move that decimal point 2 places back to there. And that of course has gone then. So we've now got 0.006, and we're going to put that in standard form. And standard form is a number times 10 to the power of something. So we need to make this a whole number, because that has to be 1 or above or less than 10. So to do that, we need to make it a whole number. We change that decimal point back, but this time it goes to there. So that makes it a 6, and it's times 10 to the power of, and because we've moved it 3 places, then it's to the power of 3, but we've moved it to the right, and it's a negative 3. Our next one, same. We've got to work out first and then give the answer in standard form. So I'll deal with this in order. I've got 40 times 30, and 40 times 30 is going to give me 1200. And I'm going to times it by 10 to the power of 5. So that's 10 times 10 times 10 times 10 times 10. And that's actually going to give me, here we've got 100,000. So I've now got 1200 times 100,000. And I can do this the nice and easy way. If I look at the numbers themselves, I've got 12 times 1 to give me 12, and then I just put the zeros back in. So I've got 2 zeros from there, and I've now got 5 zeros from there. And that's what we've now got. So if we break it up, we've got 3 zeros there, 3 zeros there, so we've got 120 million. But now we need to then go back to standard form, and that's the number between 1 and 10 times 10 to the power of something. So as we look at that, our decimal point needs to go to there to make it 1.2. And it's how many times we've moved that decimal point. And we've gone from there, we've gone 1, 2, 3, 4, 5, 6, 7, 8 times. So that's 1.2 times 10 to the power of 8. For 21, we're given a cuboid. We're given the measurements, but we don't need a ruler as such, because the drawing for the net is on a centimetre grid. So we know that, of course, if that's 2 centimetres high, it's 2 blocks high on here. A net is if we unfold the shape. Now I did say we don't need a ruler, that was for the measurements. We do need a straight edge. So I'm going to use my ID badge because it's there. And here we're given the base, so that's the bottom of our shape, and that's one side folded down and one side folded down. Now we know the opposite sides on a cuboid are equal, so that means this side will be repeated here. So let's draw that in. I'm going to use a darker colour so we can see it a bit better. So that's that side repeated. So we need to repeat that side. And we've got most of our shape now, so we've got the base and we've got the four sides, but of course we need the top as well. And the top is the same side as the base, and we can just add that on. Now where you add it on is up to you. I've seen them put over there, I've seen them placed here. I'm going to do it here because it's the easiest option. So we know that's 3 across and 5 long. And that is probably the most simple form of net that we can do for that shape, just a cruciform shape. Now I'll show you on the mark scheme, and they have got, so there's our cruciform shape, that's the one we've done, and they have got all kind of variations on a theme for that one, okay, including that one at the bottom. Yeah, they all get the mark, but you know, why make life complicated for ourselves? Go for the easiest option. Question 22 is a frequency tree, and we're given a lot of information here, and that information is, well, it's kind of straightforward really. We've got 330 students between year 10 and year 11, and it tells us the ratio between year 10 and year 11 is 1 to 2. So for every 1 student in year 10, there's 2 in year 2. So we add those up, we get 3, we divide 330 by 3, we get 110. So the 1 for that is 110, and then of course year 11 is twice as many, so they've got 220. And if we add those together, we get the original amount. We know we're right. So now the next part, we need to fill these in. And it tells us that 125 students win a medal. So between there and there, we're going to have 125 students. 73 of those who won a medal are in year 11. So year 11 won a medal, we've now got 73. So from that 125, we can take away the 73, and that leaves us with, so we take 3 from 5, leaves us with 2, I have to borrow, and that leaves me with 5. So that means I've got 52 there. And that's straightforward. And we've dealt with all the information we're given, but we've still got 2 to fill in. And this is why they're worth 4 marks. So as again, I've used my ID badge, ignore that one. From the medal and no medal for year 10, that's out of 110. So we take 52 away from 110, and we're going to get 58. And then year 11 is 220, 73 of which won a medal. So when I take that away from 220, I'm left with 147. And that's that, all done. As I say, we know that column adds up to 330, and this column will add up to 330 as well. We know we've covered everything for that. Question 23. Fractions. Now we've got 4/15 plus 1/5 divided by a half. And here we deal with the divide first. We're throwing BIDMAS in on a fraction question as well. So if I just put a line down there for now, and that's all I'm dealing with. 1/5 divided by a half. And of course we're going to use, for the division, we use KFC. So we're going to keep the first, flip the second, and change the sign to multiply. So we've now got 1 times 2, and 5 times 1 So we've got 2/5. So now we've got 4/15 plus 2/5. And of course, we can't add with the denominator different. But 5 and 15 are in the same times table. So that means I can leave this one the same. I've got 4/15, but I need to times this, and I need to make that bottom number 15 as well. So 5 times 3 gives me 15, and whatever I've done to the bottom, I do to the top. So 2 times 3 gives me 6. Now I can add them. So it stays out of 15, and 4 plus 6 gives me 10/15. And that simplifies down because we know 5 goes into both, and that simplifies down to 2/3. And there's our answer. Now, 24. Only 1 mark, so we're not really dealing with a lot of working out for this one, are we? So we're going to be doing, we've got y is equal to 1 divided by x. And we want which of these values of x gives the greatest value of y. And what we're looking at is basically if we're dividing, but we want to have the highest value, the greater value, we're looking basically for the smallest value. Okay? And as we look at that, we've got 9/20. And we look at the idea for that. If we change it as a decimal, we've got 0.45. 2/5 is 0.4. Now this one, we would have basically, I mean, it's -80 and this is 95. I mean, they are far bigger, aren't they? -80 and 95. So when we look at those, the smallest value there is the 0.4, and that's going to give us the greatest value of y there. Okay, so circle that one. Now, 25, circle the value of sin 90, so the sine of 90 degrees. And this is one of those questions, it's to do with exact trig values. There's no working out to do, it's worth 1 mark, and it's down to whether you know the table. And if you don't, then search for exact trig values or exact trig ratios on any of the websites like Maths Genie, Colbert Maths, anything like that to find that table. Now, the answer for this one is 1. Okay, no explanations, it's an exact value. As I say, look it up, because these questions are just based purely on your knowledge, not the calculation that you're doing. 26, well, we're basically there. This is the last. And what we've got, we need to work out, we've got the area of the rectangle being 120 centimeters squared, but our measurements here are in our algebraic form, and we want to work out the value of x. So the area, we're going to times the length times the width. So I've got x plus 2, and I'm going to multiply it by x minus 5. So I'm going to use, well, I'll use the grid. I always do use the grid for this. So I've got x plus 2 on the top and x minus 5 on the side. It doesn't matter which way round you do those, okay? So x times x gives me x squared. X times a positive 2 is plus 2x. Minus 5 times x is minus 5x. And then we've got 5 times 2 to give us 10, and it's a negative times a positive, so it's negative 10. So I'll put those in order. I've got x squared plus 2x minus 5x minus 10. And of course they simplify down. So I've now got x squared plus 2x minus 5x leaves me with minus 3x minus 10. And there's my first step. We've made a start on that one. But what they're telling us is that this equals 120. and we need to find the value of x. So what we do is we want to make this side of it 0, because then we can factorize and we can find the values of x. So to make that 0, I've got to take away 120, which means I now have x squared minus 3x minus 130 equals 0. And now we can work with that. I'm going to go back to use the grid, because I like factorizing these with a grid. It makes life easier. The x squared goes there, and the last part, the minus 130, is going to go here. Okay, now we know that x squared is x times x, so that means in our brackets, as we do them, we've got x something and x something. Okay, now when we think we've got 130 there, we're looking at the ways of getting to 130, and the easiest way of that is we can have 10 times 13. Now when I look at those two numbers, I need something that's going to either add or subtract. When we simplify it, that's going to get us to minus 3. So if we've got the 10, positive 10, and we take away 13, we end up with minus 3. So that I'm going to now put a positive 10 there and a negative 13. So if I did follow that through, we'd have, that would be minus 13x, and this would be plus 10x, which of course, minus 13x plus 10x, that gives us the minus 3x. Okay, didn't need to do that bit because we already had the numbers there, but it does for the example. So I've now got x plus 10 and x minus 13, and this equals 0. Now if we deal with each one in turn, I'll cover that one up first. So we've got something plus 10 equals 0, so that means that one has to be minus 10, so x is equal to minus 10. Let me rewrite that a little bit better. X equals, because I didn't leave myself enough room. And then the next one, again, something take away 13 equals 0, so that must mean that x is 13, and it's a positive 13. So as we know, when we're factorizing, we end up with two values of x, but they only want one. And because it's a measurement of length, it has to be the positive answer, not the negative. Okay, so that means that x is 13. Plenty to do there, and of course I've shown it using the grid. The mark scheme covers all of that, and I'm going to put that there so you can, if you need to, you can pause it, you can have a look and check for yours. And there's various items being, now there it says for the working out, terms may be seen in a grid. That's fine, we can do that. Okay, and again for part 3 is correctly factorizes. It doesn't specify, you don't have to use the formula, you can use the grid, it's fine. Okay, and that's us done for the full paper. Hope you did well, and I hope the video's been of some use to you, and I'll see you for the next one.